Okay, hello everyone. So I am Shoharta, and this is the start of today's workshop. Let's actually wait like 2 minutes. Let's actually wait 2 minutes if anyone else is coming in, and then we can start. Also, if anyone faces any issues, like if you want to ask any questions or whatever, you can just unmute and ask. I'll probably not be able to look at the chat box right now, like during the session. Maybe after the session ends, then I can come to the chat box. So if you want to ask anything during the session, do open your mic, and let's start. So yeah. Okay, so this is PostgreSQL full stack web development. So one of the main things about today's workshop is going to be it is going to be like very broad, which means I'll have to cover a lot of topics because full stack development consists of a number of things. Like, you need to configure your server, you need to expose your IP, you need to configure a database, then write backend code, write front end code, everything. So like full stack, it's literally in the name, it's the complete stack. So um, whatever we are doing today is actually a simplified version of like real world websites. So let's start and see how much we can cover. Yeah, so today's objectives, introduction and objectives. So I am Shohardo. I am currently an artificial intelligence major at University of Malaya, and the objectives for today's workshops are to first learn how full stack web development works. Then we are going to learn the basics of PostgreSQL and Flask. PostgreSQL, the last part of the name is SQL, which stands for Structured Query Language. PostgreSQL is just a sorry, I think you can't hear me. Hello, hello, hello. Hello, can you hear me now? Hello, hello. Okay. Hello. Can you hear me now? Hello. Hello. Am I audible now? Hello. Hello. Is it okay? Right. I think something was wrong with Discord, maybe. Do let me know if I get disconnected again. For me, it says like voice connected and reconnected and stuff like that. It just disconnects time and time again. My screen is okay. I'll start. I'll come back to the next time if you can't hear me. Okay, okay, okay. Wait. Yes. Okay. I think it should be fine now. Yeah. If anything happens again, just please like unmute and then tell me. I think now it's fine. Okay. I'm going to start now, and yeah. Okay. So I don't think you were able to listen to the introduction. Right now, it tells me that I'm connected. Okay. So today's session is on PostgreSQL full stack development, and the workshop is going to focus on Postgres, but I'm also going to show you the ins and outs of full stack development. So as in the name full stack, it contains the entire stack, which means you need to configure your server, you need to configure the backend, you need to write the front end web pages and everything. So right now, like during this workshop, we are going to try to cover as much as possible because it's such a broad topic. Um, the example I have prepared for you, it's a simplified version of like what happens in the actual tech sector. So this is full stack development with PostgreSQL. So for introduction and objective, I am currently a third year artificial intelligence student at University of Malaya, and the objectives for this workshop is, first we are going to learn how full stack web development works. uh, so we are going to start with an introduction to PostgreSQL, then we look at setting up the database, the server, and then also how to set up front-end web pages or views as we call them. Then so along the way we are going to learn the basics of PostgreSQL, which is just an implementation of SQL, structured query language. This is the language that helps us communicate with the database. And we are going to achieve this communication using Flask. Flask is a web server written in Python. So the backend code we will see today is also going to be in Python. And so finally, we are going to get hands-on practice by building a simple inventory management website. So inventory management means it's a warehouse management system for any shops or stores or marts, whatever you want. So that's it. I'm just checking if I'm still audible or not. Yeah, so let's start. First, we move on to PostgreSQL. So the first thing about PostgreSQL is it follows ACID. ACID means atomicity, consistency, isolation, and durability. These refer to the transactions, or the transactions as in the sense that data transactions. So you're communicating data with the database. This is called a transaction, and for that it follows this principle. So atomicity means every single transaction is considered a single unit. Then all transactions are consistent, which is the C in ACID, which means they happen in the same way, the same process. Then comes isolation. All the different users are isolated so that you can ensure data security. Unauthorized users can't access whatever data they want. Finally, D for durable, which means that the entire transaction environment is very durable. Screen loading. Okay, guys, is it the same still? The screen is loading, right? So is it possible to move on to a different platform, like maybe with Google Meet maybe? Because I have a 400 Mbps connection, but my Discord is messing up consistently. I'll send you a Gmail. Okay, so I think here it should be fine. I'll start presenting again. Um, Let me know if there are issues here as well, because it shouldn't be. My internet connection is very good right now. I'll just give me some time to look at it if you want. Yeah. Okay, I'm not getting any more connection requests. So okay, I'll keep adding as they come. So yeah, let's start the presentation. Still recording. Let's add this tab. Full stack of development. Alright, so let's present. Okay, so yeah, I'm really sorry for that issue. I don't know what's going on. So yeah, ACID, like PostgreSQL ACID. So ACID refers to PostgreSQL data transactions. So like sending and receiving data. This is called a transaction in PostgreSQL, and PostgreSQL follows ACID like sorry. Uh, it follows the ACID standards. So ACID stands for atomicity, consistency, isolation, and durability. Atomicity means each transaction is considered a single unit. Then we have consistency, so all transactions are consistent in the way they happen. So same data size, say will go at the same speed. There won't be any differences. And we have I for isolated. So PostgreSQL isolates different users so that unauthorized users cannot access data they're not supposed to access. Then there comes D for durability. This means the entire process is very durable and it won't just break down. Then we have extensibility. PostgreSQL offers extensive support for extensions and customizations, allowing developers to tailor the database to their specific needs while providing integration support for many languages, which means you can extend your database almost however you want, and you can use wrappers, so database code wrappers, for an array of languages, a number of languages. So later on, when I show you the code demonstration, you will understand what is meant by a database wrapper. Then comes scalability. PostgreSQL is highly scalable. It offers both horizontal and vertical scaling. Horizontal means you can add more resources to your current server, and this was the vertical scaling. And horizontal scaling means you can add multiple servers, like you can host a database on multiple servers, or you can add more servers to a single database, and PostgreSQL is going to be able to manage all that and scale itself up. So that's what scalability means. And finally, community support. Right now PostgreSQL is the industry standard, everyone uses it, so you will have a lot of like tutorials, a lot of Q&A sites, helps, whatever you want based on PostgreSQL. So moving on, how full stack web development works. So for this we for full stack web development, there can be mainly four entities. First is the server. So the server houses all the code and it exposes the backend to the internet. What this means is that there are a lot of server side not server side applications, more like there are a lot of libraries and frameworks that you can use to build a server, but on your own laptop. So right now we like today we will be using Flask. So in the current context, my laptop is a server. I am serving web pages using Flask from my laptop, but it doesn't mean anyone from anywhere can access these web pages. For that functionality, we will have to expose our IP as well as our port, so that people can go on and then type in the like IPv4 address. So type in the numerical address, or if I register the IP address for my website on a domain name server, then I can have a name instead, like facebook.com or google.com, whatever. So after we expose it, people can go onto their browsers and just type in the name and visit our web pages. This is what exposing means. Then we have backend. Backend contains the code for manipulating data, uh, serving pages, accessing databases, etc. So whatever we do, whatever the developer is doing with the data, however he wants to present it, this is done using the backend. Then we have the database. Database just stores the data. We can like send new data to a database, we can retrieve data, we can update existing rows and columns in the database, we can do all sorts of things. And there are mainly two types of databases, relational and non-relational. So for today's lesson, we are going to focus on relational databases, which means there will be the tables in our databases are going to be related to each other. So next we will see an entity relation diagram, then I can explain this more. And finally we have the front end. Front end is just the web pages. So web pages or views, whatever you want to call it, this is used to present the information that the developer wants to the outside world. So to set up our development environment, I personally use VS Code, but I will recommend Sublime Text a lot, because VS Code, it has a lot of extensions and a lot of people use it, so there's a lot of community support. Same goes for Sublime Text, but because VS Code is a bit easier to use, so a lot of people shifted to VS Code now. But if your own system is low on RAM or other resources, you should go for Sublime Text instead of VS Code. And then PostgreSQL, you just need to download and install. You can follow any YouTube link, whatever. I don't want to show you how to install it. It's not it's not anything vital or very important that I have to show you. And then command line. So you will use some command line command line functionality today, mainly git, and then for PSQL. So SQL like engines, like SQL engines like PostgreSQL or SQLite or even MySQL, all of these come in two forms. First, all of them have like a UI, so user interface, that you can click and do all that stuff. So like the current what you're seeing right now, this is called an UI, and all of them also have a CLI, command line application. So what I'm going to show you is the CLI, how to use it. And using a CLI is more convenient once you get used to it. you just type it. You don't even need to lift your fingers from the keyboard. So it's just faster if you are used to it. You can also use the GUI, that's not an issue. So yeah. Now we move on to understanding relational databases. So a relational database is a type of database that organizes data into tables with rows and columns, where each row represents a record or an individual like piece of data, and each column represents a specific attribute or field. So the relations between tables are established using keys such as primary keys or foreign keys, which maintain data integrity and facilitate data retrieval. So there, most of it should be easy to understand. There are two new terms, however, foreign key and primary key and foreign key. So a primary key is an unique identifier inside any table. So all of your tables should have a primary key associated to it. The project we are developing today is going to be very simple. So the diagram you see on your right, it's called an ERD, entity relationship diagram. So this is the ERD for today's project. What it is that there are three entities. First there is a customer entity, then there is a product, and finally a transaction entity. So the customer entity, it has 4 columns, product has like 5 columns and all that. These just define a single customer or a single product or a single transaction. However, as you can see on the left columns, there's a PK or FK keyword. PK means primary key, which is the unique identifier. However, FK means foreign key. So foreign key is used to relate different tables with each other. So right now only transaction table has foreign keys. So what's a transaction in an inventory management system? A transaction is like selling or buying an item. So instead of having it like this, like referencing customers and products using a foreign key, if we didn't do this, then for each transaction we would have to manually input the name, like the details of the customer and the details of the product, and then the number of columns for the transaction table will explode. Usually there are like, I don't know, every single database I have worked with in a professional setting, every single database has around 20 tables, and then every single organization has like 20 or so databases. So 20 times 20, that's 400. So if we don't establish relations with foreign keys, then we'll have to include all 400 columns in one single table. This is just an example, but in this case it's actually true. So right now transaction ID, like transaction table, it has a transaction ID which is a unique identifier, and it refers the customer with the customer ID who performed the transaction, and then it also refers to the product which was used in the transaction with the product ID. So later on we will see join commands. Join commands are an example of how you can establish relations between two tables. So yeah, that is the foreign key. The other column, discount rate, is just a regular column. So yeah, understanding SQL. SQL, or structured query language, because we are structured. Why structured? Because we are dealing with relational databases. So the tables are related to each other. That's why it's that's why to like work with such databases we need a structured language. So what we are going to use is SQL. When you Google SQL or like SQL engines, you are going to see a list of different terms like PostgreSQL, MySQL, whatever. So all of them are inherently the same, but all of them have like very minute syntax differences. So syntax differences and other like database engine differences, but that's not an issue right now. We are focusing on the language. The next few slides we focus on the language only. So usually, like, the majority of the terms and the functions are the same. There are some differences, so it won't matter to you much. You can just start with whatever and then switch to another engine's language in no time. So yeah. So it stands for structured query language. You can access or manipulate databases. And here we learn a new term, CRUD. So SQL lets you create, read, update and delete data. So CRUD applications are basically, you can implement CRUD applications with SQL, and CRUD applications have become a big like thing in the tech industry, because it it's very convenient, and you can deal with relational databases very easily and very intuitively using CRUD methodologies. So SQL lets you deal with CRUD applications. On the right, you see an example of a SQL query. Also, as you can see in the bottom, it took 0.004 seconds to run this query. So when you're actually building stuff, then you will have to worry about how fast your query is running and how much memory it's using and all that. But right now, this is just an example. Although it looks big, it's actually quite like easy. They're just selecting, which means taking data from certain tables and then performing intersections on a condition. It's just that. It's actually very easy. Anyway, so let's start learning SQL commands. The first one is select. Select statement is used to select data from a database, which means here, like, select star from customer. I have a okay. This is actually a database I have set up for this workshop. Yeah, it's here. So I can just so then I should actually show you how this works. So I have already installed PostgreSQL, and PostgreSQL comes with a command line interface, which is called SQL shell for PSQL. So you all of this is default for me, so I just put the default names and port numbers for everything, and I set a password. So I just connected. Never mind, I put the wrong password. Now slash. So I have a number of databases, so I'm just going to connect to the database for today's workshop. I named it Creno, so I'm now connected to Creno. Now slash dt. These are the tables in the dataset from a previous slide: customer, product and transaction. You can use d plus to see details about a single table. So you do d plus, you see there are 4 columns in customer ID, name, contact, email. There's actually an error in this slide. If you see here, the primary keys are set as integers. Let's not do that. Let's set them as serial, so they auto increment. Otherwise you will have to keep track of the last ID and then increment the next element you insert manually. Let's not do that. I made that mistake, but later from now on we'll just use serial. We'll actually not use serial today, but keep it in mind. When you are using primary keys, make it serial. So yeah, now I won't run every single command. I'll just show you the first one. So select star. Star stands for everything. Star just means everything in the CS jargon. In a CS jargon, star means everything. So take everything from customer. One thing you should note about PostgreSQL also, I'm really sorry if you can't see the font. I can't increase it. but it's the same as the select star from customers. That's what I wrote. So PSQL is case sensitive. And one other thing is, when you are referring to database entities, you must put them inside double quotes. So this is a double quote, this is a single quote. For string literals, so string literal is just a string, so like this. String literals you need to put inside single quotes, but database entities you must put inside double quotes, otherwise it won't work. So select everything from customer. If I do that, then there are 3 customers. These are random data I input beforehand, so that's that. This is the select statement. And the first few are not much. Then we have insert. So to insert, we have the insert into statement that is used to insert new records in a table. You can insert one or multiple rows in the same statement. So as we can see here, this is the statement is insert into customer. The syntax is insert into table name, then in parenthesis you need to write the names of the columns that you're inserting into. So columns, because they are database entities, so these go in double quotes. So customer name, customer contact, customer email. Then you close off this this statement with the ending parenthesis. Then you specify the values. So the values are John Doe's phone number, and John Doe's email, and then other 3. And then if you want to insert multiple, you need to do the same. Like you just need to write the values. You need to write the column names only once, and then you can write the value tuples. So these are actually called tuples. So Jane Smith phone number example. So this entire thing inside parentheses, this is called one tuple. So the value tuples, you can separate them with comma and then just insert. And you can also insert like just one row using this like format. So insert into customer, you again need to specify the columns, and then values are Harry Maguire, and then Harry Maguire's phone number and his email. So that's it. If the insertion was successful, PSQL will tell you how many like rows were inserted. So insert 0. So for rows, how many? 3. So 3 rows were inserted. Here you're inserting only one element, so only one row, so only one was printed. And you can also put arbitrary new lines. So this will work. I'll just type out this command for you. Yeah, this command. As you can see, this is one command. Insert into customer, whatever values Harry Maguire, but I have it on 2 different lines 41 and 42. This works. You can SQL like the CLI will keep accepting input until it sees a semicolon. So when you're using the CLI, you need to finish your statements with a semicolon. So I do that, then insert 01. So one row was inserted. Maximize. Yeah, you can have the slides, but command font maximize. You can maximize the command font here. Okay. So this was the insert statement. After insert, we will have update. So update is just updating an existing row. So the format is again update table name, then you need to write set column name equals value where product ID is something. So here we learn a new keyword, actually 2 new keywords, set and where. Set is just setting the value of a column, but this is the second one, where this is actually quite important. you will use it a lot. Where is just a condition, so it's an if condition. So where product id equals 1, this just means if product id equals 1, then update the product table and set the product quantity column to 15. So it will go inside the product table, and then it will obviously, it will first go inside the product table. The flow works like this: we go inside the product table, then we check which row has product id equal to 1. If we find that row, then we set the column value, in this case the product quantity, to the value specified. And then again, if the update was successful, it will say update and the number of updates. So we can just write it. The update is here. As you can see here, this command is actually divided into like spread in over 3 lines, and it will still work. So update 1, actually nothing updated, because I think the product quantity value was already 15, but it will still say update 1 because the command worked. So we move on to delete. So delete statement is used to delete existing records in a table. So this is very self-explanatory. So delete from customer, again delete from table name, where customer name equals Harry Maguire. So we had Harry Maguire inside before. Now we are going to delete him from the table because no one wants him. So delete from customer, delete from table name where a condition matches. If this works, then PSQL output delete and then the number of successful commands. So that is, we inserted Harry Maguire before. This is okay. This is fine. So let's delete. Do I not have the delete string? Okay, I forgot to write the delete string in there. So anyway, so delete from table name. I just pressed enter and went to a new line. Also, if you notice here, if it's the start of a new statement, then it says creno, then equal sign, then a hash sign. But if it's a continuation, then it says creno dash then a hash sign. So if it's inside a statement already, then it will just say hash instead of it will just say like a minus sign instead of equal sign. So where I think it said customer name, where, so because it's a database entity, so I'm putting it inside double quotes. Customer name equals Harry Maguire. The value is going, the string literal has to be inside single quotes. I finish it off with a semicolon and done, and delete one. So Harry Maguire is deleted. So so these are actually the basic commands, and now we move on to some advanced SQL commands. So first we find joins. So think of if you remember, like I think like 9th or 10th grade mathematics, you studied sets and then union and intersection. So joins, you can think of joins as unions and intersection. A join clause is used to combine rows from 2 or more tables based on a related column between them. So this part I will not show code right now. I'll show the code later when I showcase the project. So right now I'll just explain what it is. First we have inner join. Inner join is just intersection. So a join just like matches rows between 2 or more tables, and how this match happens, you can specify that using like a suffix. So inner join, outer join, then we'll have left join, right join. All these suffixes specify how the join occurs. So inner join, it it just selects records that have matching values in both tables. So matching values based on a column. So I'll just write a line of code for you. So to show you an example. So okay. Oh, sorry, it was actually code for an outer join. Inner join is this one. Never mind. I'll just copy paste this. Yeah. This is called running. Just put the command here and explain it to you. So this is an inner join. So select everything from product, and then inner join transaction on product dot product id equals transaction dot product id. So every single join happens on the actual keyword is on on a single column. So both tables must have this column. So if we go to our, actually the ERD is a bit far, so no, I should show you. So if you go to our ERD, then you can see that the product table has a product ID, and the transaction table also references the product ID column from the product table. So we can perform joins on the product ID column. So select everything from product and then perform an inner join on transaction. So the base table is product, and we are performing the join against transaction on product ID column. So if I'll actually leave it in, it will go on GitHub and you can come back to it later. So I'll write it here, just copy paste it, and this will output all the common values. So how do you know these are the common values? So inner join means common, they have to be in both the tables. So I can just select everything from product, and then select everything from transaction. So as you can see, inside transaction there are three product IDs, 1, 2 and 3. 1, 2 and 3 are the first two smartphone, tablet, and the last one laptop. The output for the inner join also has only these three product IDs, 1, 2 and 3: laptop, smartphone, tablet. So inner join is the it outputs the common terms from both tables. Also, one more thing you should notice is that the output contains all the, it just merges all the columns and sends the output. So we have the first 5 columns from product table: product ID, product name, product description, quantity, price, as well as the 4 columns which came after, because transaction is a table we are joining against. So this one comes after. We have transaction ID, customer ID, product ID, and discount rate, everything. So this is how inner join works. We will just update. We didn't make the change. Select product. customer. So no, sorry, transaction. Yeah, here I'll just comment it out so that this doesn't print anymore. So that was inner join. Next we have full outer join. Full outer join is just union. It gets everything from all the tables. So we still need to match on a column. So like if that column for the rows that that column exists, we will get all those rows. It's actually the same case for like, because if the column exists in a table, then the column will exist for all rows. So when you're performing full outer join, you will actually get all the rows. There are no scenarios where you can not get like one or two or like any number of rows if you're performing full outer join. So next we have left join. So left join, it just returns all the records from the left table and the matching records from the right table. So yeah, it's just that. I can show you an example. You can let's just also look at right join. Right join returns all records from the right table instead of the left one, and then returns whatever is left in the right table. So right and left, it just returns the right or left tables. If I do like an example, so transaction get function get join, just followed by, yeah, here we have code for right join. I'm printing like the right join. Right join. Okay, let's predict what will happen if I print the right join. Okay, so okay, if I do right join on product and transaction, so the right table is transaction. So transaction has 3 rows, product has 5 rows. So right join on product and transaction will return only 3 rows, which will be like 1 2 3. 1 2 3 are laptop, smartphone and tablet. So let's print the query. Actually no, let's come here, let's do a right join. So we are predicting that it will return only 3 elements. So yeah, it returned 3 elements, which are laptop, smartphone and tablet. So this was right join. Now actually not much is left for like me talking. We have some advanced SQL queries. First is group by. Group by statement groups rows that have the same values into summary rows, like find the number of customers in each country. So this kind of query is going to be like select everything from customer, select not everything, select name from customer, where select name from customer, group by country. So here name and country are 2 different columns, and in that case the output will only give you the number of users or like customers in each country. You can also use certain aggregate functions such as count, max, min, sum, average. These are just what the name implies, to group the result set by 1 or more columns. So what you can do is find the like you can write select sum of customers from customer. So actually you can write any column inside sum. So sum of customers from customer, group by country. So this will give you the number of customers in each country from the customer table. Then we have a having clause. It's used to filter the results of a group by statement, because we can't use where in a group by statement. So for that having like how we used where before. We said like where name equals Harry Maguire. So say we need like information about all the Harrys, then we can add having uh, Harry, like the word Harry with the query, and then it will give us the output for all the rows that contain the word Harry. Then we have some easy commands like drop is used to delete entire databases or tables, so you can just do drop, uh, the drop name of database, it will drop the name, the database, or drop name of table, you can do that. Or you can use truncate. So truncate will wipe out a table, so it will delete all the rows or records in a table, but the table will remain in, like the table will be there with like zero entries after you perform a truncate command. Then we have the alter table command. Alter table actually modifies a table, like alters a table. It is used to add, delete, or modify columns in an existing table. So you can add a new column, or you can say change the data type of an existing column. You can also add or drop constraints. Constraints are like foreign key or primary key constraints. So say you forgot to add foreign keys on a column in any like table. So from like previous examples, maybe you forgot to put add the foreign key constraint on customer ID inside transaction. So what you can do is you can perform an alter table command and uh, add the foreign key constraint to that column. So yeah, and then finally this will actually come after the project presentation. So security testing and deployment, all that. So before that, I should show you today's project. Yeah, I made some changes to the code, so I'll just get ahead and then git push. Okay, so today's project is this. Again, let me run the server first, otherwise it won't work. So this is the project. It just shows you all the information that is stored inside the database, and it shows you the outputs of certain like database queries. So this part is here because I want to show you how we perform database queries in production. We don't write SQL anymore, we write wrap we use like libraries or like wrappers. So yeah, so this project is made using Flask. Flask is it's a simple server like server framework, server library, mostly a library written in Python. So for this you can write code in Python and all that. So this is very easy. This is actually not this is not very like this is not easier than other languages like Node or whatever, but this is still helpful if you want to fire up a small website very fast. So yeah, so first we're importing Flask, and then we're importing a function render template and all that. So we should actually look at the file structure and the installations. So for the file structure, I have an app.py. So app.py is actually the entry point of your server. So when you are writing backend code, you are serving the backend code alongside your front end and database or whatever with a server. So right now the server is actually a work zug. So this one, this is the server. It's called work zug, maybe German, I'm not sure. So this comes with Flask. So workzip comes inside our project folder, and it looks for a file called app.py. If you don't name your file app.py, you can just specify the name when running the server, or like when running the application, but because I have it named as app.py, I don't have to. I can just type flask run, and then the entire thing runs. So that's that. So I have an app.py, that's the entry point. These files requirements, readme, commands, git ignore, git ignore, these are not required at all. The next file that's necessary to look at is the .env file. .env files store like important information that you cannot disclose to the public. So inside this .env file, I have the database configuration information. So user password, port, host names, all that. Mainly these first 4 lines of information, if a hacker gets to know these, then they can get inside your system, and that's not what we want at all. So how do we defend against that? We put everything inside a .env file, and we import that file using decouple, or literally a library called python.env. So right now I'm using decouple. So from decouple I'm importing a function called config, and this again goes in my project folder, finds the file called .env, and grabs the values for these names. So here I have specified db user is Postgres, so it's just grabbing the value for db user. So this was .env. Then I have a virtual environment. This is entirely for Python. I have other projects running or like develop on my laptop as well. So I don't all of them use a number of like libraries and frameworks. I don't want dependency or like version control issues across all the folders. Some projects need like very old libraries, like very old versions of libraries. Some projects need new versions, so I don't want to install a single version across my entire laptop and then break past or like new projects. So what I do is I create virtual environments and run new projects inside that. This is not, you will obviously do it when you write production code, but this is not very like very much related to our current project. And then we have 2 folders, database and templates. Templates is the front end web pages, like just the views. So this is an index.html file. I have defined it inside index.html, which is inside templates. Templates folder. I heard a noise anyway. So this again is a very simple file, a basic HTML. I am however including bootstrap, and then I am displaying all the information as tables, so table rows and table headers. Finally, this is the database. This part, like this code actually communicates with the database. So here to communicate with the database, like mainly PSQL, the most popular library we use is scopg2. So I'm importing scopg2.pool. So pooling is it's just connection pooling. So I have a database instance running. So this is my PSQL database instance that is running on my laptop. I need to connect to it. So I connect using like connections. It's actually called a connection. To be honest, first I get a connection, then I generate a cursor from there, then I can perform queries. But yeah, first I need a connection. Every single connection it takes up RAM, and it actually takes up RAM. So every single connection is actually very like memory heavy, because you are dealing with this database is very small, but in production you have to deal with very large instances of databases. It will have like millions of rows and columns, whatever. So in that case, we don't want connections to be lying around, because connections are using up system resources. So what we can do is we use connection pools. So connection pools is, it's just like a pool or a bucket. It contains a fixed number of connections. So right now I have specified that the minimum number of connections is 1 and maximum is 20. So it will never exceed that, like 20 connections. If it goes above, like if I ever ask the program to create a 21st connection, then it will stop running. That's what will happen. So yeah, this is a connection pool. So every time we want to perform a database query, we take a connection from the connection pool and then perform the query and return it back to the pool again to be reused. So uh, in so yeah, this helps prevent system resource abuse. uh, so that was connection pooling. uh, these like keyword arguments, this is just for starting a connection with the database. So the database is secured with credentials, user credentials. So you need to provide your name, password, and also the port number. So you need to specify all these when you are creating a connection pool. So yes. So this was done, the pool was done. We have at least 20 connections at our disposal. We can just call them, use them, and then return it back to the pool. The connections are not closed per se, because we're not closing it. You have to call connection.close. I'm not doing that. I'm just doing pool.putCon. So I'm returning open connections that can be reused later. So yeah, it can be reused later. So that yeah, that was it. This was it for pool and psychopg. Next we have from databases we are importing customer, product, and transaction. So in production, this is actually a bit easier. Like this representation is a bit easier. In production you will see classes. So every single, you will represent every single class, every single table as class. So for customer, it's going to be a customer class. You will define the columns like this, so self, customer id, and all the other columns. And then you can do representations or other functions that work with the customer table slash the customer class. That's how you work. But right now I don't need all that, so I'm simply writing functions that communicates with the database. Here I have another import. So this is the wrapper. So instead of writing raw SQL query, I'm using Python wrappers. So as you can see here, PostgreSQL dot from customer select everything. So this is the same as writing select everything from customer inside this shell. But I actually won't have access to the shell because I'm not running the commands, right? This program, this server is running the commands. So I need to I can either like write the strings by hand, or I can use a library that generates strings. So usually it's done like this, because otherwise it raw dealing with raw SQL strings, it can become a bit difficult. This is more structured. You uh, so here I'm just importing PostgreSQL query. Again, because I'm using a PostgreSQL engine, I need PostgreSQL, and this is just a class table. So what this is doing is it is creating it creates a customer table, because I have a customer table in the database. Then uh, I only need to worry, or like I only need to keep in mind that this spelling customer, it has to be correct. Later on I don't need to worry about anything, because these wrappers. So from, for from, then select. I don't need to worry about spelling, I don't need to worry about retyping, whatever. All of that was done once when the PyPicker programmer wrote this library, and that's it. I don't have to worry about anything. So code clarity and code maintainability becomes like very easy when you use wrappers for databases. So yeah, so we create a customer table, then we generate queries using PostgreSQL, like the PostgreSQL class. Then this part is actually getting the SQL string, so query gets query.getSQL. Now how a server communicates with the database: we first need a connection, then we need to open a cursor. The cursor executes the query. So this connection I am sending from here, like the app.py main file. I have the connection pool inside the main file, so I have the connection as an argument to all these functions. I am sending the connections from this main file, uh, so that I can keep track of every single connection that are being made in this, because I know I'm only generating new connections. So pool.getCon inside the main file, so there are not going to be other files who will hold or hog up connections and hog up system resources. So which is why I'm getting this con variable from the main file. So I'm generating a cursor, the cursor is executing the query that was generated here, and then we are getting the result using fetch all. There are like fetch one, fetch all, fetch many, I think. So these functions that you can use to get the result of the query. Then we must close the cursor, otherwise we are leaving system resources like unattended, and it will like we're basically wasting RAM. So we need to close the cursor, then we're returning the result. So this is so basically I have different files for every single table. All these are contain definitions from different definitions for different functions. So inside product I have left join, right join. Inside transaction I have full join and inner join. So these are basically defining what I can do with those tables, and then I'm importing all those functionalities from the database folder using this line. So yeah, so until now we have a server, we have the database configured, and we know how to communicate with the database tables. So now let's create the app. So this is you just call app flask, it's double underscore, it's actually called dunder, d for double and then under dunder. So flask dunder name. So this is the name of the file, and then we're calling flask and generating a flask, an instance of a flask class. So this is the app, and then this app will help us serve like pages or templates in the future. So in production app you have what are called routes. So the home page or the home route is just a slash. You can have other routes like slash I don't know, slash, you can just have like index.html or slash user or like slash login. You have all these different routes. So these are what comes after the IPv4 or like your website address. So inside your server, like inside your server file, like this one, this isn't actually the server file, this is the backend file. A server file is something else, how you expose your backend to the outside world. So inside your main like entry point for your backend, that file, you need to specify what what the server serves on each route. So right now I'm saying that app.route slash forward slash, this is the home route. On this route we are going to serve index.html. So here I'm just getting all the information from the database. So generating connection, then getting all customers from customers, then getting left join from products, getting right join from products, full join and outer join from transaction, and then putting the connection back in the pool. So we are getting the data first, then we are rendering a template. This template is inside the templates folder. This is necessary for Flask. You must put all your templates inside templates folder. uh, Otherwise you need to write a URL for function. That's the syntax for that is a bit tricky. So if you don't want to do all that, you can just do this. Render template, name of the template index.html, which stays inside the templates folder, and you specify the variables you want to go with it. So I have customers, and then two types of products, left join, right join, and two types of transactions, full join and inner join. So because I am doing it like this, customers gets customers, product left join gets products dot left join. So I will be able to use this, like customers or products left join, these variable names inside the template file. So index.html is this one. This is a template file. What I mean by using those variable names inside here is, if you see here, I actually have a for loop for customer in customers. So customers is a list or an array or whatever. So for every customer inside the customer list, I'm doing something with it. So if you, this is how, if you specify the inputs as like arguments like this, as keywords arguments like this, you can later on reference the keywords inside the template file. So this is the final page, actually the template. So this is just there are like 4 tables inside body. This part isn't really necessary. These are the heads, or the table heads. So this part, customer ID, name, contact email, I'm specifying specifying the name of the columns inside a T head element, and then I have a T body element that contains the like the table body, so all the rows. uh, there's actually only one last thing to notice. HTML files are not supposed to contain Python programs or code or anything. HTML will only contain HTML or maybe JS code inside a script tag, but that's not really our point right now. But in no circumstance should an HTML file contain Python code. How we can do how but as you can see here, we have like Python code inside HTML. How this is done is, you need to specify which part, like yeah, basically like what is the Python code, like which part is the Python code inside curly braces. So this is called a curly brace, and there are like 3 types of curly braces for like for loops or if clauses. So for clauses and blocks, you have curly brace and percent sign. You need to write for statements or if statements inside curly braces and percent signs, and then you need to write the values for variables inside double curly braces. So what I'm doing here is for customer in customers, for val in customer. So after the database query, like PyPika, the PSQL wrapper, PostgreSQL wrapper, it actually returns data as a list of tuples. So tuples uh, tuples are just like lists, but they are immutable. So you can't update tuples like lists. Like in Python, if you have a list like this, or in any language, if you have a list like this 1 2 3, you can just append uh, whatever you want to it. But if you have a tuple, like onto it, you can't append to a tuple. So yeah, attribute a tuple object has no attribute append. These are immutable. So because database rows are actually immutable, like after you retrieve them, there is not really any point in updating, because that's after you retrieve them, that data is the result of a query. So you shouldn't really mess with it unless you want to generate something very different or like very new. So because say you query the customer table, you get all the customer information, but when you are outputting it, you increase the age of the customer by 20. It's not something you should do unless that's the exact use case for your program. But yeah, to retain the accuracy of the data, PyPika returns it as a list of tuples. So for customer in customers, this is the list. We are iterating the list, and every single element is a single customer or a single row. So for val in customer, so basically for every single value like customer name, customer contact, inside the row or customer, we are outputting it as like a th. So th, I think table header or whatever. So like t row. So yeah, it's actually like a it's actually just this, like a single value th. I think it shouldn't be th. I think it should be td. I don't know why I put th. Wait, let me change. This should be td. Yeah, see, because it was th, everything was bold, but right now only the column names are bold. So yeah, so you iterate over every single row and then just output the data. uh, Also, you need to close every single statement. So this is a single statement. You close it with like double parenthesis, double curly brace, but every single block statement you need to close it with another block, so like an end block. So end for. If you had if statements, then you would write them like this: if customers none, then dr just no data, whatever. But you must end the block. So this is how it works. So there are actually three uh, block, then just values for variables, and the last one is comment. So this is a comment. It's in green because it won't execute either in Python or in HTML. The server will ignore this. So this is how you can declare like template files and then append data to it, so manipulate it. And yeah, the, so I'll just like show you an example and finish the session. I'll actually update. So maybe okay, I will add a new product. So right now there are 5 products. I'll add a new product, and then you will see left join on products and full join. These two tables will have 6 rows, but right join and inner join will still only have 3 rows. So let's do that. Insert into double quote product. I need to put the column names. So column names are because I have serial, so I don't it auto increments, so I don't need to input product ID. I can just start with product name. These should be in double quotes as well because they are database in entity. Sorry, I messed up there. So insert into product name. to say val, then you end the column name tuple and start the value tuple with values. So value is going to be product name. Maybe we don't have an item, so this one will go inside single quotes. So item, web description, image equals rows, product quantity maybe 5. The store has 5 items. Product price is 120 maybe. End it with a semicolon. Done. Insert 01. So all of this is in real time. So if I now reload this page, left join and full join, will have 6 rows. Yeah, see, there is a sixth element, like sixth row here as well. But inner join and right join don't have that, so it works. Yeah. So I think that's that's it for today. Ask me any questions if you have any, and yeah, today's workshop is done. Sue isn't here, right? Okay. Yeah, if there are no questions, I'll just in the meeting here, I'll send you guys the GitHub link, the slides, the code. Yeah, the code is inside GitHub, and I'll send the recording to Suhaila, and that should be it. Alright, thank you everyone for joining. You can reach me on Discord whenever you want. I am Roberto Key. So yeah, see you all later. Thank you.